Hey everybody, good afternoon, good morning, just depending on where you are, good evening. Just want to come in really quickly and make sure that you guys can hear me okay. Can you guys just give me a thumbs up if you guys can hear me? Lots of echo. Okay. Can you guys hear Brian? Okay. Um,
So I'm set up. The test is saying you should be able to hear me, but apparently you can't hear me and I can't hear you. One problem, it might be affecting it. I'm using Edge browser, and I know that's not one of yours, but in Microsoft machines, it automatically goes to that. Not sure a good way to get around that. I have Chrome installed, but when I click the link, you know what I mean? It says I'll send you an email link, and as soon as I click it, it goes to the wrong place. See if that can.
okay. So I'm assuming that you guys can hear me okay, but Brian's voice is a little bit faint. Just bear with us 1 second and we will get that fixed for you guys, okay? So sorry about the delay. Hang tight, guys. Okay, guys, Brian is going to go ahead and reconnect and then log back on, and then we'll go ahead and get started. I'm so sorry for the delay, but if you guys haven't had a chance in any of the previous sessions, or if this is your first session, please feel free to answer the poll questions while we get everything squared away. And also, we would love to know how we're doing. We're so sorry about the volume on our end, so we apologize for that. But please let us know how we're doing, how you guys are liking us. Like I said before, you guys can follow us on Twitter at Pragmatic Works or connect with us on LinkedIn. So just give us a few more minutes here and we're going to get Brian logged back in and make sure that his sound is correct. So please just feel free to let us know in the chat how you feel like we're doing, and also feel free to answer the poll questions. We'll get started in about 10 minutes. You guys just hang tight, okay?
Hello? Let me try. Let me try switching to just communication. All right, hello?
Hey, Brian.
Oh, can you hear me now?
If
Can you hear me?
okay, Yes, I can. Can you hear me?
Yes. Eureka.
All right, awesome, awesome, perfect. Okay, so I'm gonna go ahead and let you go ahead and get started. They're pretty much already warmed up, so they're just waiting on you. So if you want to go ahead and share your screen, you can get started, okay?
How do I share my screen?
If you go down to and hover over your icon, there should be like a little laptop with a arrow through it, and they'll allow you to share your screen.
Okay, one sec. I'm sorry, I'm missing. I see clip, I see live, I see a chat window.
Okay, so right where your icon is, down in the left-hand corner.
Okay.
There you should see the microphone, the video, the HD, and then you'll see the laptop.
Oh, okay. And okay, and I think I got it. Share screen. There we are. Okay.
All right, the floor is all yours. I'll let you know when your screen pops up too, as well.
All right. Thank you.
Mm-hmm. Brian, just to let you know, we still don't see your screen, and I don't think the audience does either because they're saying
okay. Let me check. Okay. It's cycling.
Okay.
It's trying to share. Yeah. How many people are in the class?
We have about, looks like the number's still going, about 100.
Wow. Yeah, I don't know why now it's just spinning on the screen share.
Okay. Do you want to try to refresh your browser really quickly?
Just cycle the window.
Mm-hmm.
Wait a minute. Oh, I think I figured it out. Now you should see it.
Okay.
Let's see.
All right. Perfect.
Oh, let me get rid of that one.
It's loading. It's coming up. Yep. Now we see you.
Thank you.
And you can go ahead and get started whenever you're ready.
Okay, so everyone should be able to hear me?
Yep, we can all hear you.
Great. All right, so welcome everyone. Sorry for some technical difficulties. Kind of new to the technical getting into this system. My name is Brian Kafke. I'm a data and AI solutions enabler from Microsoft. The content slides and one sample, I think two sample notebooks are available on my GitHub account, github.com/bkafke/shared. And this is all about the Azure Machine Learning and a lowercase s service, which I'll explain a little bit later. But when we're talking about this specific service, Microsoft documentation tends to not put a the before it and use a lowercase s, as opposed to other machine learning types of services. So a little about myself. I'm a Microsoft Technical Solutions Enabler. As I mentioned, I have decades of IT experience. Prior to joining Microsoft, I was a data platform MVP as well as a cloud and data center MVP, 2 different years. I wrote a book called Pro PowerShell for Database Developers. Experience in a number of industries, and I lead a SQL Pass chapter, which is the Rhode Island Microsoft BI user group, and also a data science user group up in the Boston area. And very proud to be a nerd. Do a lot of videos on YouTube and everything, and I'm always looking at new technology. Feel free to reach out on LinkedIn. My link is there. Just my name, Brian Kafke. You can find it. And yeah, reach out. Let me know that you saw this if you liked it and things like that. This is also, I have a YouTube channel, and this particular video, what we're going to go through, is covered in 2 different parts of YouTube videos. So feel free to take a look at that. Subscribe if you're interested in a lot of nerdy technical topics. I kind of cover a wide range of things, obviously PowerShell to data science. My real central area is also data engineering, big data. That's been kind of my big thing since I got at Microsoft. So yeah, please check out my channel. And something that you may not know about that's a great learning resource is Microsoft Learn. So if you go into Bing or Google and just type in Microsoft space Learn, or find my documents, you can click on this link. This will bring you to a completely free, self-paced micro-learning, they call it, Microsoft. Really kind of fun place to learn about all the different Azure technologies, and even beyond just Azure, but Office and all these other things. So really good place to go. And what's nice about it is, without even having a subscription, in many places you can actually get the benefit of a virtual machine and things in Azure without having to pay. So what are we going to be talking about? It's going to be a little bit compressed. I think we did lose a few minutes in the beginning, but I'll try to get through as much as I can. Before I even go through this, I do want to emphasize that this is not a simple concept to get your head around when you talk about doing data science in Azure, because there's so much being automated for you that it's kind of the integration of many technologies, as we'll see. So the conceptual side of this is really important. So I will do a demo, but in this case, and it's probably one of the only places in all the things I've used where I'd emphasize that getting your head around the concepts is really key to getting into things, even before you start trying to do everything. So what I'm going to talk about the data science process, and that will lead us into what the Azure Machine Learning Service is not, and then I'll talk about what the Azure Machine Learning lowercase s service is. And then I'll talk about the Azure Machine Learning Service, it should be lowercase s, but and the data science pipeline and how this fits into it. And then I'll talk about solving machine learning problems. And of course, the whole purpose of the Azure Machine Learning Service is empowering everyone on the planet to do more and be productive, and just, in this case, leverage data science. So you may have used something called Azure Machine Learning Studio, and this is not what I'm going to be talking about, although the service has a graphical front end that looks similar to this, which I'll hopefully maybe able to show that for a second. But this is not that. This is actually going to focus more on using Python to leverage Azure services to do a lot for you in data science. So it's targeted more towards that. I had a lot of involvement in the data science certification for Azure called DP100. And so this is actually something that's leading to what will be the down the road topic that focuses a lot on DP100. Right now, there's some work going on in that exam. It is also not Machine Learning Server, which is running on SQL Server. So that's another thing I need to dispel. It's a great product, but this is strictly an Azure-based product. So it is about the data science process. So when we think about data science, it really starts with, what are you trying to accomplish? Most projects and companies does. And so here the objective is, what are you trying to do? When we talk about data science, typically it's trying to solve something with some type of predictive modeling or some sort of AI that's going to save the company money or provide better service or provide revenue, maybe a revenue stream. So a good example of this would be, for instance, if you're in, say, insurance, identifying fraudulent claims could be something you might want to be able to do. In healthcare, you might want to reduce readmission. So your idea is, can we identify people who are likely to be readmitted, and then maybe do some intervention things, or be more cautious about following up with people who are dismissed from a hospital, so we avoid those readmissions, because Medicare doesn't like to pay you on readmissions, so you have to be really careful with that. So define the objective as the beginning point, then you collect data, and this is a very iterative process, so it's not like your typical IT solution. If you're not familiar with data science, you don't just start writing everything and you're done. You look and say, what data do we have to support this? And it's an iterative process too, and like, what do we need for data? But once you have it, you prepare the data, you clean it up, and then developing the model. A really good substitution word there would be feature engineering. The idea is, you're going to figure out what data is likely to help us predict something. So you leverage historical data to train a model. And once you have the model, you want to then run new data through. Somebody comes to the hospital, they're being checked in, maybe they have some cardiac issues, and it can look, and based on data, if it's, the model would then say, this person is likely to be readmitted if you send them home, that kind of thing. So the feature engineering end of that is, you have to figure out what elements of data are likely to help. So it might be the number of times a person has been readmitted in the past, the person's age, comorbidities, which means the other diseases they have. For instance, maybe they have pulmonary issues and things. So putting things together, maybe they've had a lot of issues with following up and taking their medications, compliance. So those things could lead you to be able to predict likelihood of someone being readmitted. So once you have that, then you train the model using historical data. Typically use about 80% or so of the data you have, train the model, and it's just basically calculating statistical models of likelihood based on the input data. And then you hold back a little bit to test the model. And then you kind of go through this and you may try different models. So one of the challenges in data science is figuring out what model is going to be the best one, and something we'll talk about, hyperparameters. Once it's good, you publish the model, which means you make it available so that web applications or maybe mobile apps and things can leverage the model. Might be in a hospital, like in the readmissions case, maybe Epic system, which is a really popular EMR, emergency medical record system. It might be that would call something and say, is this person that I'm checking in likely to get readmitted? So you want to make sure that model is available. And also you got to think about, how am I going to scale the calling of that model? So let me step in a little bit. So getting into this a little bit more in detail, we'll talk about defining the question. And it could be, in this case, an example, I think I have an example I'm going to walk through, which is in a clinic, for instance. Imagine there's a problem of low birth weight babies, which means high mortality and health issues with the baby. So could we reduce that? So in the clinic, you could look at historical data and identify attributes, maybe demographics, health issues, et cetera, blood pressure, et cetera. And that might lead you to be able to predict, is a particular instance of a mother expecting, is the baby likely to be a low birth weight? So what data would I need for that? In this case, you'd probably look at sort of historical data around birth weight, mother's age, mother's weight, whether she has high blood pressure, cardiac issues, any number of things, and that may factor into whether or not this is likely to be a low birth weight baby. Then you're going to prepare the input data. So in this, you want to clean up the data. It has to be clean. If you get a lot of nulls, you're going to have problems with getting good predictions. Outliers are things like when you have values that don't seem right or just unusually high. So for instance, you might have a blood pressure that was incorrectly entered. I saw this in a company once. The person would have to be dead to have a certain blood pressure. So obviously it was not correct. So you have to decide what to do with that. And also, a lot of times you might want to, for instance, in a case like this, count the number of times a given expecting mother has had low birth weight children in the past. So if this is a third or fourth birth and you see that previously all 3 children had low birth weights, then you have a pretty good probability probably also there. So that would be an example of aggregating and preparing the data. And then you want to experiment with various models. There's a lot of different types of models. This is typically the thing that most people new to data science are the most intimidated by, but it's not really that bad. There's a lot of ways to kind of approach this. But I will point out one thing. Typically, you're either trying to calculate one of two things. Either you're picking a classification in which it's like, will this be a low birth weight baby or not? Yes, no, or one of 3 potential values. Or you're doing continuous variables, like what will our sales be next year, the year after? So that is the biggest splitter, but going on. So classification, logistic models, deep learning neural networks, these are all possibilities. Then you want to pick what's the best model. So let's say we pick this thing called KNN classification model. That's great. There's a process you have to go through, say, okay, try each one and just see. It's kind of like going into a store, you try and close, which one fits the best. And finally, you deploy the model. And so now you have questions like, do we deploy it on our own servers on premises? Do we deploy it to the cloud? Which cloud, et cetera? So the Azure Machine Learning Service is designed to support all of those questions and all of that process. Most of it is actually at the later end, so I don't want to overemphasize that. But when you talk about figuring out, for instance, or sort of the data prep, you can either do that on your own machines or you can do it in Azure. But the places where it's really going to help is the later stages where you get really confused, like what model is the best. There's something called AutoML. We'll take a look at that. So what is this is something when I had to get my head around this, I wrote some of the content on the Learn platform that I mentioned, and I was trying to get my own head around, well, what is the Azure Machine Learning Service? What's a good way to explain it? I would say it's bringing the power of containerization and automation to data science. So what do I mean by that? And this is really critical to appreciating what's going on, so I'll kind of emphasize this a bit. When we talk about containers are really sort of the core of creating things on the cloud, right? So we have virtual machines, which is a complete sort of pseudo machine that's created magically in the cloud that acts as if it's an actual machine box. And within that, there's something scaled down version of that, which is instead of creating the entire machine, we just create a subset, and that's called a container. So you've probably heard of things like Docker and Kubernetes, and that's a containerization service. So the ability to leverage that containerization with data science is one of the key benefits of the Azure Machine Learning Service. The other one is automation. So another piece in this is you've probably heard of things like DevOps and how DevOps will orchestrate from the beginning to the end all the way to deployment. That's another feature that the Machine Learning Service offers. A bunch of other things too, which we'll talk about, but it's that ability to orchestrate a lot of different cloud services to really benefit data science, because data scientists are typically not heavy-duty developers. They don't want to be writing pages and pages of code. They're not launching web apps. They're trying to solve a data problem. And so we want to try to bring that to the data scientists and make it easier for them to leverage cloud services. So it supports model training, deployment of models, model management, like tracking what models have been created, how they're working. Are they starting to get what's called data drift? So they're not picking, they're not as accurate as they started out being. And so getting back to the containerization, if you think about, if you're not familiar with containers, an entire box would be a virtual machine. But when you talk about containers, you're really talking about you have one common operating system, and then you have this software called a hypervisor, and then with that, you'll have a sort of a separate box that's going to run an application. And within the same virtual machine, you can actually create multiple boxes essentially to run your app. So if we had something like a Python library, and we're using a library you'll see called scikit-learn, and that's going to actually do a classification model, we could create a container and run it, or we could create 3 containers or 100 containers. And the nice thing about it is they're all running in separate units, and so one could go down and another one will still take over. And when people want to call your model, you can create as many containers as you need to service the model, and that'll be all managed for you. The application would just have a REST API and it would call it. So when you create these containers, what would you need? Well, you need your Python, you need your model. You're going to put that in the container. You'd need to have the Python libraries. If you're using pandas, scikit-learn, etc., it would need that. But you don't have to worry. The container itself, the service handles the operating system and things for you. And hypervisor is what manages these containers. So we have a shared OS, and the hypervisor manages environments, and then we have our application. So why would we use the machine learning service? Well, one of them is the complexity of configuring and deploying containers. I'm not really big on lots of configuration and having to look at JSON files or XML files or something to figure out what I need. And so I like stuff that makes it as easy as possible. And that's really one of the main goals of the machine learning service. Also, speeding up the process. It can take a while to train models, compare models, and figure out which one's the best. Deploying models is a huge problem, because if you are familiar with things like HD Insight or Databricks, one of the things that happens is you need this massive compute, that scaled up compute, possibly a petabyte of data, to train your model. But you don't need so much compute to deploy the model, because what it produces at the end is a fairly lightweight program, which will do predictions. So then you can put it somewhere else where it can easily be used. So those are things that are really beneficial to the service. Can be added. So you can add or remove any parts of the service you want to use at any point in time. So it's not a you have to use everything. You can pick and choose different parts of the service, which is great. All right, so let's kind of step back and say, what are the challenges in data science? One of them is, what features will you need to predict an answer? That's a challenge. How do I scale up machine learning training? So again, Databricks is an example where you need massive scale to train a model. Deployment is actually a separate side of the same coin, but deployment gets to more the point of, okay, I've got a really small program. It's not big, which is the function that will now predict. But how do I make it available so that thousands, maybe even millions of people can use it quickly? So that's two sides of the issue. How do I know what model is the best one to use? And there's a thing in model training when you're doing machine learning, you have to give it what they call hyperparameters, which are basically, if you think of model when you're training, you're calling a function to train a model. These are function parameters to the algorithm. So there's sometimes it's how many depth levels do you want to go in certain models? How many things do you want to consider? So hyperparameters can be time consuming to use to figure out what you want. And then tracking and managing models. Data science tends to be very immature in the sense of tracking, management, source code control, and et cetera. And this is what the service will help you with. And we've talked again quite a bit already about deploying. So these are all things, and automating the whole pipeline from end to end. I kind of think it a little bit like an ETL pipeline. You get your data in, you push it all the way through. The only difference really is that you get it at the end and you start turning it into features, which you then push into a model to be trained, and then you want to deploy the model. So it's a fairly complicated process. So in a normal machine learning pipeline, as you see in this diagram, you start with data ingestion. So again, it does remind me a little of ETL, but the only difference now is you're getting into, okay, how do I prepare my data? So there's these things you can do, normalizing, transforming data, and featurization. And then once you get to that, you have all these other things you have to do for hyperparameter tuning. The service allows for automatic model selection, so it will actually pick it for you, model testing and validation, and finally you need to deploy. So this is kind of the end-to-end process. And the ML Services really handles this last section the best. There is a data prep toolkit, and a little sideline, if you've ever heard of the Azure Machine Learning Workbench, the Workbench was actually targeting a lot of the prepared data side. That's now turned into an open source SDK, a set of libraries in Python you can use to do that. Not really leveraging the machine learning service, but the right side is where we're going to really focus. So getting back to our original list of questions, these are the areas you can see: experimenting with various models, picking the best model, deploying the model. That's called model management. And you also have these features, automated ML and hyperparameter tuning, special features within that. So we'll kind of look at that more closely. So you can easily extend existing machine learning pipelines to use different features you want to use, automated feature selection. So you can also actually have the service try to figure out, if you're not sure what columns will help, the service can help pick out which features are likely to produce the model. And the nice transparency feature in it, I don't get to talk about here, but just be aware, if you're in an area that's heavily regulated like banking or healthcare, you can have some transparency in the model where it will tell you what features are driving the answer, which is really important if you're in, say, banking, because you want to make sure you're not inadvertently redlining, where you cut out certain areas and the model has sort of figured out that, you know, in certain areas they're not going to get as many loans. It might build that into a model, and you can get into problems with regulators if that happens. So the transparency there is really good. Automated model selection and model management and logging. So as you'll see, I think we have some demo code here. I'm going to try to jump into some demos soon here. So I'm going to jump through a little list, but one key takeaway also is that we can deploy the model and get a REST API back, and then we don't have to worry about how to call the model and make it available. At the current point in time, there's two ways you can use the service. One is a visual interface, which I'm not going to get too into, and the other is through Python. Okay, so I'm going to get into my demo now. First thing I want to do is to get into Azure. Should have got into Azure. Okay. So if we go into Azure, we can see a bunch of things. I'll go to my dashboard, for instance. But what I want to show is I'm going to show you how to first create a service. So if I'm going to say create a new resource, okay, I'm not sure why it's not responding. Oh, it's a little bit slow here, sorry. It might work it's from here. Okay. Let's recycle the screen here. Okay, so see if it'll let me create a resource now. All right, I'll take the, it's giving me a little trouble here, so I'll use the menus on the side here. What I want to do is create a machine learning service workspace. It's a very common paradigm in Azure that when you want to do something, you got to create a link basically between your account and a bunch of resources that will tie you back to your subscription. So when we're doing this, we would use, and let me, I'll make this a little bigger so we can see it better. but we give it a workspace name. I like to put my name in the beginning or something, but so I could say like this is my initials, BPC workspace. I'll say MLS W workspace. You can say what subscription. Generally, if you're going to do anything in Azure, I usually like to start with RG, and then I'll say BPC MLS W. And I'm not going to create this because I have a lot of resources, but the point is a resource group is like a box, and you put everything into it. At the end of your training, your developing, whatever you do, if you don't want it, you can just delete the resource group, and that will get rid of it. So that's that's another thing to bear in mind. I like to do that when I'm creating new resources. And if you're using Azure or you're starting on the cloud experience, I highly recommend you work carefully to figure out what's a good resource group strategy. But again, a resource group is just a big box you're putting things into. I'm actually on the West Coast today, but normally I would be creating it in the East Coast region. And that's all I need to do. I'll say review and create, and then you just click and go. It's going to create a bunch of stuff which I will show you, but I just wanted to kind of go through that. So let me go to my dashboard. So I'll show you. It's kind of like baking show. I'm going to say that's what you would do, but I'll bring out something that's already prepared. Okay, so we have this, I'll use this one, the workspace demo. Now, a couple of things that's really useful when you get here is to notice assets. So within the workspace, we have experiments, we have pipelines, which is like end-to-end ETL and model training. We have compute. We're going to create, for instance, maybe we want to train a model. Maybe we want to train it on something like a Spark cluster because it's big data. Maybe we want to train it on a high-powered virtual machine, et cetera. So the compute defines what do we need for computer resources. We have models. So I kind of click in there, and the models are actually, when we've got a model, we can save it and catalog it, and that's stored here. So we have all these artifacts. Here's one I did earlier. We have images. So kind of taking the computer step forward, if you've used Docker, then you know Docker has images. And so the image is really more for deployment. You've trained your model, it looks good, you're ready to deploy it, make it available to your applications, and now you can define an image and catalog it. So when you want to deploy it, we'll pick up that image and say, oh, okay, you need Python, you need these libraries, you want it to run on Windows or Linux or whatever, and it will have all of that defined and just deploy it. And then you have deployments, which is the actual artifact that defines how something should be deployed. And I don't have any here yet, but there's a lot of different things here. And notice above, you also have this pipeline stuff. Now, another thing you have that's pretty cool is automated machine learning. I mentioned is you don't know what you need. You don't know what model to use. You're not sure how to set the values. So this is a new preview feature. Automated ML can be used in Python, but here's is like a walkthrough GUI you can play with. If you've used Jupyter Notebooks, you can also create notebook virtual machines that are linked directly to the AMLS workspace. And that's really nice because now you have Jupyter Notebooks and integration. I'm going to demo from just regular Azure Notebooks, but that's just Jupyter Notebooks. And I'll just real quickly go into the visual interface, which is in preview. So again, I hold back a little bit when something's in preview, fully promoting it, because it usually means there's some features that are still missing. It may not be fully tested. Things could change. But the main takeaway when you get in here, it may take a minute to go. Oh, that's interesting. Let's see. Sorry. Okay. And here we go. So you can do a quick tour, but I'm not going to do that. I just wanted to kind of show you what it looks like. So you can kind of walk through this. If I have any open things here. But if you've used the AutoML, the ML Studio, then it's similar. You have data sets, you have experiments, and you can drag and drop. If I had this one earlier. And you get kind of a nice visual for it. You can see your tracking, your model, and they've made a lot of changes to this. So this is one of the reasons why you do have to be a little bit careful when you're using something in preview. But the basic part of this is that it's a visual interface just like AML Studio. So that was really just what I wanted to kind of show here. browser's a little slow. Okay. But this is where you can see it looks a lot like Studio, and it's very, my guess is, I don't know for certain, but I think what's happening is that the GUI interface that you've used to on AML Studio is being migrated to be a front end to the service, which is a really great thing for customers, because one of the problems with the AML Studio is that it didn't always scale so well. If you had billions of rows of data, if you wanted to use Spark in the back end, you want to do certain things, it wasn't really the best for doing some of those things. Whereas now that you're going to get a GUI front end and the service, you're going to get pretty much unlimited scale and a lot of flexibility and integration that you wouldn't have had before. Sorry for this taking so long here, but I'm not going to stay, so we can imagine that we'd see visual icons there, but it's taking a little slow. I think my connection is just a little bit too slow here. So let me go step back for a minute. So the takeaway, if I can go back here for a minute, that I just was trying to drive home is that there's a lot of different components that are part of the service, and you can manage everything from within the workspace or directly from a Jupyter notebook using Python. So let's take a step back, and I'm bringing in an Azure Notebook. Azure Notebooks are great, free. I have a video on YouTube, so you might want to take a look at those. But I just want to kind of give you a feel, like what would it look like if I were doing things using Python to do data science, and then also using the Azure ML SDK. So this is typical kind of stuff in Python, importing a lot of libraries. But notice you can see it's importing the Azure ML core. And oops. It's okay, that's not good. Let me close my notebook and halt. Okay, I just want to be careful there because I just rearranged my stuff. But it is, the Azure Notebooks are a great resource. And one of the nice reasons for using it, if you're going to do data science with Azure, all the SDK modules are pre-installed, which is great. Now, when you first get in here, what's actually happening is you're getting a virtual machine for free to run your notebook. Now, I typically like to put the print statement, if you notice, at the bottom on a lot of code, because sometimes when you're running a notebook, it hangs for a while and you're not sure when it's actually done. So I like to do that. But here I'm bringing in the Azure Core libraries. It's going to say print when it's done and that kind of thing. And you can see over here, usually when it's dark, it means it's running code. Okay, so it takes a minute because I had to start the VM plus do that. So there's a lot of stuff in here. And oh, I do want to refer back to one thing. When you are in here, if you go to the overview part of the workspace, there's a lot of great resources, getting started, documentation, and most importantly, this link is really useful because it brings you to free notebooks that you can learn and play with. So this is how I actually first got started. There's tutorials here. You can load these notebooks and do the ones I'm going to demo, for instance, just go in and play with these. It's a great way to learn the service. So what we did, kind of just to demonstrate, what this cell here is doing is just loading the libraries we're going to need. Then what I want to do is I'm going to use, now I've already loaded a configuration from Workspace, so I can load my Workspace like that, but we'll kind of step through. But you can define all kinds of definitions of what you want your workspace to look like when you're working. We created it, so I want to back up for a minute. You can create your Azure Machine Learning workspace in the portal, or you can do it directly in Python using the SDK. You see that we have that here. And here we're going to just kind of load some data. This is pre-available data to make it easy for demonstrating. As I mentioned, you don't really see anything, so it's kind of helpful to do this just to make sure it did what I want. Okay. And here we can see, okay, we're training a model. This is just explaining the details behind the model, but we're going to run a little tight, so I just kind of want to demonstrate. I'll just kind of step through the code. What we do is we want to set up auto machine learning. And so what we want to do is we want to run through a model, and we want Azure to pick the best model. And so what we're trying to do here is we want to pick we're going to do predict numbers that are in images, and we want to have it identify it, but we don't want to have to train the model ourselves. We want it to tell us what's the best model. So we're telling it it's a classification model We're going to say, how should it be evaluated as far as which is the best? So we're going to use this thing called AUC weighted. We're going to tell it, we have to feed it what's the X values, what's the Y values, so that the Y is what you're predicting, the X is the input data. And a really key thing here is how many cross validations, like how many comparisons do we want, and how many times do we want it to iterate? So the more you make the iterations, the higher you set that, the better output you'll get, but you also pay more. So that's really key. And just run this and run that. So now we've defined our settings, and we can say, okay, I'm going to run it. Here's my experiment, submit. And now it's running. It says on a local machine, which means it's this for testing purposes. Typically, we'd set it up and run it in Azure. But here we're going to get automated ML, and it's going to be using our local compute to do it. So we can see here, I think this is kind of a cool thing. You'll see it iterating. So it'd say, okay, I'm in the pipeline. I'm going to run one model, see how it does. I'm going to run another model, and it'll just keep logging it. And let's see if it gets through at least one model here. But you'll see it go through one, and it'll tell you what the model is that it's running. And eventually at the end, it will come back and say, this is your best model. So in the interest of time, I think I'm going to step back. Hopefully I can come back and show it running. But a faster way to run it would be to use compute. And go back to the notebooks and GitHub, and you can find all examples of different ways to run it. And one of them would be pushing it into Azure and using more heavy-duty compute, so it will come back faster. Okay. And this is another way we can run the models. Let me kind of go through here a little bit. Yeah, this is just giving us more information. Sorry. So I want to show here is once you're done running, you can take that pointer, which is where we ran the model, and we can say get output, and then it'll actually return in Python what they call a tuple. So it's going to give us back the best run model, and that'll actually come back as our model, or the best run or best fitted model. So the fitted model that we ran. So let me see if it ran through. So you can see now, great. Got through one of the models, and it'll keep doing that. It should stop at three iterations. So I think 3 models. And this is just really showing how you can print some things out of it. And so you can now take the best run and the fitted model. And the nice thing about it is then you can take that model and say, okay, this is my best model, and then go through steps to deploy it, and it'll be available. So the main takeaway, I think, from this is you are using Python, and you have the SDKs. So for data scientists that already really like to use Python, by just extending their existing code with some extra Azure features, they can take advantage of a lot of cloud resources, such as automated ML, deployment to the cloud, training in the cloud, etc. And if you go onto my GitHub account, if you want to look at, I think I have another sample notebook, you can go there and also get that. But again, going to the workspace itself, you can always find resources there. And this is a really great resource here because you can step through a lot of these notebooks and see different types. This image classification is kind of a cool one. It takes images of numbers and translates them and gives you a prediction. And you get to see how you would implement that on using the machine learning service. All right, so let me kind of go back to a few slides. This is just kind of some images here showing you, and this kind of shows you that you're using Jupyter to create your training models just as you normally would, kind of showing out how hyperparameter works. So what is the service? And this is a short presentation, so you're not getting as much depth. Typically, I would talk an hour and a half or so, but I did want to point out that when we think of the service, the biggest takeaway is the Azure Machine Learning Service is the core backbone of all data science on Azure. It is becoming central so that when you think of the GUI interface, as I mentioned, I showed you that exists there. Power BI, when people talk about doing Power BI of data science, they're talking about the machine learning service. Dynamics doing machine learning. If you do IoT Edge and you want to do machine learning, you typically would connect it in and run it through the service. You also have Jupyter Notebooks and, of course, Python. Now, I will really highly recommend that if you're going to use the data science service, the machine learning service, use Azure Notebooks just to save yourself trouble of trying to make sure you get the configuration of libraries set and things. The SDK is very new, and so it likes to be up to the latest versions of Python. But I found that on the Azure Notebooks, the free version, mind you even, you get all that out of the box. You don't have to worry about it. So this is kind of another slide that talks more about the deployment workflow, and it kind of shows you just end to end. Another key takeaway, though, is think about it's trying to package everything you need to do in the data science workflow and put it together into one integrated service. So things like DevOps, containerization, deployment, it's all there. And it has all of these artifacts that it stores and catalogs along the way so that you can track everything. And if a model starts performing poorly, you can go back to an earlier version, things like that. So it's finally bringing really more modern types of features into data science, which have been sorely lacking. Okay, I think we talked about some of these things, but these are features you can do. And it is getting close to the end, so I want to step away for a minute. And let me go back to see if I can catch any questions. Okay, so I did have a thing about, can we go over, I guess that's a question to Pragmatic Works. Is it okay to go over a few minutes, or are we kind of constrained? Okay, I'm looking at the chat window. Does anyone have any questions that I can answer?
Hey, Brian, yeah, and it's totally okay if you go over a few minutes. You guys take your time. I know we were late getting started, so go ahead.
Okay. Okay, great. So are there any questions anyone want to type into the chat window? I'll try to answer any questions you have. I know this was a bit crowded for a lot of information, a bit of a data dump, but hopefully I've conveyed the main ideas. All right. Not seeing any questions, so.
If you look down there where you see the polls at, there's 3 questions in the question panel down there. Where's the next question?
All right. See, I'm learning here. What percentage of your data is currently in the? Okay, so.
The other one.
Okay. Oh, ask a question. Perfect.
Yeah.
How do you calculate the cost of using Azure ML? I wish I could say there was an easy way to do that. I would say there's a pricing calculator in Azure. So that's certainly a place you could start. The challenge is, what resources do you want to use? And in data science, that's really hugely variable. So if you're going to say, I want to use a Spark data cluster with 1,000 nodes to train big data, then obviously you're going to get into some heavy costs. If you said, what I was doing, I'm using a free notebook and I'm using local compute storage. I was actually using Microsoft's free notebook. So I'm getting really cheap compute, and I could train a model that way and then deploy it. So I can get away really cheaply. It's going to be a matter of what resources I choose to use as part of my data science process. My best advice would be, I like to start slow and then add a little bit and add a little bit and then keep looking at my subscription cost. It tells you daily what you're costing. So that would be my best bet for that. So is there a free trial version of the account of Azure ML? It's very close. If you noticed, again, using the Azure Notebooks, I'm getting a lot of free compute. I didn't even use Azure's compute to do my model training. I used the Auto ML service a bit. So that would be pretty cheap. You can go in, create the workspace, and then delete it when you're done, just to save resources, money. Again, do that on the resource group level. But unfortunately, I don't know of a free subscription level for Azure ML, but you can, of course, get the free Azure 30-day subscription. So what's a good use case? That's a good question. So what a good use case for Azure Machine Learning Service is really anything that fits the data science pipeline process. So a business comes in, they want to go end to end, and especially for existing data scientists who know Python, it's a great place to say, we want to build it, we want to be able to track it, we want to make it enterprise grade. We want to know, every Friday at a certain time a model gets trained, we bring in fresh data, we score the model, we compare it, we're integrating it with DevOps, and we want to make sure an application can easily get to it. A lot of the pieces that I've seen in data science, it's not a simple thing, for instance, just to put a model out somewhere where it can be used. That's really gets beyond the complexity I like to deal with. So the idea that I could say, oh, I trained a model, even in, say, Databricks, I can just take the model and push it into containers really easily. So that's any kind of place like that. But really, when you want to build data science solutions, machine learning models, I would say look at it, and pretty much it would do any of those use cases. Yeah, so how do we know which model, classification, et cetera? That's, like I said, that's like the biggest question everyone asks. the biggest differentiator is whether it's a continuous value you're trying to predict or some sort of list of values. Like, is someone a Republican, a Democrat, or independent? Is this fraudulent transaction or not? That's the first split. But within that, there's a lot of different possibilities. And it really, so a lot of depends. The auto ML feature will allow you not to have to worry about that because it will tell you. But classification models are doing, certain groups of things. They're saying, is this a dog, a cat, or whatever? That reclassification, and continuous would be, what would be the blood pressure for a person likely based on these factors. I'll admit ignorance here. I said, can we take a PMML model and deploy it in Azure ML Service and call it at scale? I don't know what a PMML model, like, I'm guessing the ML stands for machine learning. So sorry, I can't really help on that. But when you deploy models, essentially in Python, you would extract it as a pickle file, and then you would push the pickle file into the model storage, and then you can put images, et cetera, around it, and you can create that whole pipeline. So it's there's also Onyx. I know it can support Onyx and a couple other formats, but the default one that you see a lot of examples is Pickle. But take a look at the GitHub account and those notebooks, because they explain a lot more. Which GitHub is good to you? So again, the link, I go into the service, and let me see if I can, I'm in the right place. Yeah, let me go back a bit. I'll save you the trouble in case you don't want to have to pay just to get this link. So that link will get you to the machine learning notebooks, and that's a great place to start. Again, look at the Learn platform. There's stuff available there, and if you just Bing or Google Azure Machine Learning Service example notebooks and things, you'll get things there. Put URL here. Okay, I just pasted the URL. Can you guys see it? Yeah, paste it again. Not sure why it's doing that. Okay. Okay, it's telling me I already did. So that's the URL. Any good links with books to real examples? Again, I would point to Learn, and a really good place also, a wealth of information is Microsoft Docs. It's a great reference, and there's tutorials in there. So if you don't mind cutting and pasting, Docs has some really nice walkthroughs. I will point out that this is not a trivial thing to learn. So don't beat yourself up if you're like, why am I not getting this? It's so difficult. It is complicated to a point. Parts of it are easier than others. AutoML is actually very easy to use, which I do like. When you're going through and saying, I've got a model and I want to train it in the cloud, I've got some examples, my sample notebook. I block out areas like, this is what Azure, you code for Azure. This is your typical Python code. So that's the challenge, is you kind of have to mix normal Python code, I guess, standard open source code, with the calls to the service. Again, the example notebooks is the best way. That's what I do. I just refer to it and say, oh, okay, I can see what it's doing. What I find the biggest challenge is when I'll be honest, when it doesn't like something, it can be difficult. You get one of those dumps of all kinds of messages, and you have to kind of scroll through a bit, and then you'll see some like invalid data frame type, or you're sending me invalid NumPy array or some weird thing, and oh, okay, it doesn't like this data type. So that would be one thing I'd be careful of. All right, so I think I've got the questions answered. Yep, so thank you all for participating, and again, reach out on LinkedIn, connect with me, and check out my videos, because a lot of things like this I cover on that, and you can take your time and go through it as you like.
All right, thank you so much, Brian. We really appreciate you hosting. And as for anybody else, if you guys want to jump into the next session, please feel free to, in the left-hand corner, if you just click the More button, it will drop down to the menu. You can click on the next session. If you guys have any questions about this session, please feel free to reach out to myself, or Brian would be more than happy to help. Thank you guys so much for joining, and we hope that you guys enjoy your second to last session of the day of Azure Data Week. Thanks so much, guys.
Thank you.